I'm Anil Kumar sharing with you questions from test paper on introduction of vectors. We have 10 questions in this test paper. I'd like you to pause the video, copy these questions, answer, and then look into my suggestions. I'm going to solve all these 10 questions for you. So have a look at these first 6 questions first. Let's talk about it. Question number 1. Sketch in 3D graph depicting position vector OP where P is located at -3, -4, 7. Describe the octant in which point P lies, right? So this is the position vector OP. Question 2. Simplify vector expression AB minus AD plus BC plus CD. Question 3. Unit vectors A and B make an angle of 50 degrees. Calculate magnitude of 2A plus 3B. Question 4. Under what conditions is magnitude of A plus B is greater than magnitude of A plus magnitude of B? Explain your answer. Question number 5. Given magnitude of A as 10, magnitude of B as 14, and A minus B magnitude as 19, find magnitude of A plus B. Question 6. Given A equals to vector A equals to 4 minus 3, 12 and vector B equals to I minus J, find unit vector A minus B. Right. Now here are the other 4 questions. Question number 7 to 10. Question number 7. What is product of vectors A and B? We have taken the same vectors as in 6. Is it scalar? Is it this much? Vector or not defined? Question 8. Provide example for 3 linearly dependent vectors in a rectangular prism. Question 9. The sum of 3 unit vectors is 0. Find the angle between them. Question 10. Prove that the vectors -3, 4 and 3, 2 can span any vector xy in R2. So I hope the questions are straightforward. I'd like you to pause the video, answer these questions, and then look into my suggestions. So let's begin answering them one by one. Question number 1. Sketch in 3D graph depicting position vector OP where P is located at -3, -4, 7. Describe the octant in which the point P lies. So there are 2 parts to this question. So let us first sketch and then we'll describe the octant in which it lies. So let us say these are our x, y, and z axes. The vector OP is located at -3, -4, 7. That means along the x we have to move -3 units. -3 will be going backwards, right? So this goes, let's say 1 unit, 2 unit, and 3 units back. So that becomes the position -3, correct? Then it says -4. Positive y is in the going right. Now this is -4, so you have to move in the left direction. So it is, let's say 1, 2, 3, and 4, right? So that becomes -4y. 7 up means you have to go up 7 units. So let's say we go up 7 units and get to this point. So that becomes the vector which is OP. So we have to show this vector. It's a position vector. So from the origin to the point. So that is the vector which is OP. Do you see that? So that is how you're going to sketch the vector OP. Normally you might get a triangular paper to sketch it. You can actually form a triangular prism here and then also see where in which octant it is. Now when we describe the octant, so that is the first part. Now let's talk about octant. So OP we are seeing is a vector which is -3, -4, and 7. Now this minus means what? It has gone on the back side. Is it okay? So this is on the back side. And -4 means on the left. And 7 means above. So that is how we are going to describe the position. So the octant is, there are 8 octants, correct? So the octant in which this point exists is the one which is on the back, left, and above, right? So the octant is located, or the point is located, octant is back, left, and above, right? So that is how you're going to, so it says the point P is in octant which is at back, left, above, right? So that becomes the position. So I hope that is absolutely clear, right? So remember there are 8 octants. Position of the first octant is fixed, which is all positive here on this side, correct? But for the others, we described with their position as it could be back or front, left or right, above or below, right? Okay, let's move on. Now we have question number 2. It says simplify the expression AB minus AD plus BC plus CD. First idea is write all these expressions as positive. So we could write this as AB. Negative AD could be written as positive DA, correct? So that is the first change which we made. Copy the rest as such. So that should be the first step. Now we can rearrange. We are going from A to B and then from B to C. So let's rearrange this. So we are saying A to B. So rearrange the order. Now we'll write B to C and then C to D, right? So there's a connection, there's a flow, and then D to A. What do you notice? You notice that from A you went back to A. Is it okay? A to A. That means a 0 vector. Do you see that? So that is your answer, 0 vector. Question number 3. Unit vectors A and B make an angle of 50 degrees. Calculate 2A plus 3B. So what we are given here is that we have 2 unit vectors A and B. We want their sum 2A plus 3B. So let us say that one of the vectors is like this, unit vector. The other vector is, let us say, at an angle of 50 degrees, let us say this, and this is their unit magnitude. So when we say 2A, that means, well, let's say this is vector A. Let me write down. So this is my vector, unit vector A. This is vector B. The angle between A and B is given to us as 50 degrees. Now when I say magnitude of 2A plus 3B will actually extend these vectors. So 2 times A means twice, so that becomes twice. As far as 3B is concerned, it will be 3 times, so the magnitude gets multiplied 1, 2, and 1, 3. Let's say that becomes, right? Now, to get this sum, we'll actually put the tail on the head to get this sum, right? So we'll draw the vector from here parallel to the given vector. And the resultant is going to be from the starting point, which is tail of A, to the head of B, which will give us the sum. So that becomes the sum 2A plus 3B, right? Since the vector here is twice A and the vector here is 3 times B. Now what is this angle between them? What we know is that the angle between them is given to us as 50 degrees. So that has to be 180 minus 50, right? So this angle is 130 degrees. Does it make sense to you? So we have to use that angle. So that is the first thing. So the angle theta is actually equals to 180 degrees minus 50 degrees. That gives you 130 degrees. and then we'll apply cosine law. So I hope the steps are absolutely clear to find, right? So then we'll apply the cosine law. We already know that the magnitude will be 2 here and 3 there, correct? And we want to find this magnitude. So let us say the square of this magnitude. So let's call this as, okay, let's say 2a plus 3b whole square is equal to a square plus b square. So this is like magnitude is 2, right? So it is 2 square plus 3 times b magnitude becomes 3 square minus 2 times 3 times cos of theta, which is 130 degrees. Is it okay? So that is what we get, right? So let me push this a bit on this side. So we get this as 4 plus 9 minus 4 times 3 is 12 cos of 130 degrees, right? So let's figure this out using calculator. So calculator we have to set in degrees, so which is 3 here. Now 4 plus 9 minus 12 times cos of 130 is equal to 20.71, right? So that is the magnitude square. Remember that. This is magnitude square. So the magnitude here will be of 2a plus 3b equals to square root of 20.71. So that is square root of our answer is equal to 4.55. So that becomes the magnitude of this particular sum. Okay. So have a good look at this solution and then let us move forward to question number 4. Question number 4. Under what conditions magnitude of a plus b is greater than magnitude of a plus magnitude of b? Explain your answer. Now, you can always find sum of magnitudes in vectors using triangle, right? So, in a triangle, sum of two sides is always greater than the third side. Correct? Now, when we say a plus b and a and b, so what we're trying to do here is that we have vector a and we have vector b. So their sum is actually the third side of the triangle. Since in a triangle, sum of two sides is always greater than the third side, we can never have this possibility. Do you see that? So therefore the third side can never be greater than those two sides, right? So therefore, magnitude of a plus b is never greater than sum of a and b. Is it okay? That is very important, right? However, it is important to note that if both are along the same line, let's say, then they can be equal, right? So we could have a condition of equal if they are in same line, collinear. That is possible, right? But it cannot be greater, right? That's very clear. So I hope this is clear, right? Question number 5. Given a and b magnitudes, and a minus b this time equals to 19, find sum, correct? So let's try to understand what is given to us and how to do such questions. A minus b means what? So if I have a vector like this, right? So a minus b is, let's say we are here, this is a and this is b. So that becomes a minus b, right? So this is a minus b. Do you see that? Where one vector, this one is a and this one is b. So that becomes a minus b. Correct? So that is how you kind of sketch a minus b vector. Now, when we have to find a plus b, in that case, you will notice that the angle will be 180 minus that angle. Right? So A plus B will be, you have to, from head of this, you have to draw another line here, and then that vector becomes A plus B. So we have to find that angle for A plus B. Is it okay? So this is what you need to understand very clearly. So given A minus B, we can find angle. Let's call this angle as phi, and then that angle will take up as 180 degrees minus phi to find A plus B. I hope the strategy is clear, right? So let's use cosine law. So we have A minus B. Let's find the angle between A and B using this formula. Perfect. So we are given A minus B, which is giving us that particular angle phi. Okay. So let's figure this out. So what we have here is magnitude of A minus B is equal to magnitude of A square plus magnitude of B square minus 2 times magnitude of A, magnitude of B, and cosine angle between them, which is phi. Now this is given to us as 19. So 19 is equals to 10 square plus 14 square minus 2 times 10 times 14 cos of phi. We can bring these terms to the left side, so and then solve for cosine phi. So we have cos phi equals 2. So when you bring this and that on the other side, we get 10 square plus 14 square minus 19, square. Let's write down squares here. Divided by 2 times 10 times 14, right? So let's do this. And then we'll find cosine of this angle. So we have 10 square plus 14 square minus 19 square equals 2 divided by 2 times, within bracket let's write 2 times 10 times 14 equals to negative 13 over 56. Negative 13 over 56. Now that clearly means that the angle is in quadrant 2, right? Since we got negative, that means the angle is in quadrant 2. So let's find the alpha here, and then we'll do 180 minus alpha. Is it okay? Let's find the alpha angle, and then we'll do 180 minus alpha of 13 over 15, the positive one, right? So we'll say cos inverse of 13 over 15. So shift cos inverse. You could do direct also. You may get this angle, but it is better to find the acute angle. 13 divided by 15 equals to 29.92. So let's write 29.9. So this angle alpha equals to 29.9. So that means phi is equal to 180 minus 29.9. Is it okay? So that is the angle between these two vectors. So which is 180 minus 29.9 equals to 150.1. 150.1. So that is the angle phi between these two. Do you see that? How did we find alpha? We found alpha by using cos of alpha, the acute angle, which will be here, alpha, is equal to, 13 over 15, correct? So alpha equals to cos inverse 13 over 15. So that gives us the answer, 29.9. But the angle phi will be now in quadrant 2 because it is negative, and it gives you the answer 150.1. You could have done direct also. You could say cos inverse, shift cos inverse of negative 13 divided by 15 equals to. So it does give you 150.07 rounded to one place, 150.1, no problems, right? So at present it is not a problem, but when you are doing with, sometimes it gives a problem, right? Especially if you are doing for, I mean, yeah, you may find more than one angle at times. Okay, anyway, now the idea here is that when you do a plus b, in that case the angle theta, now what is this angle? Sum of these two angles has to be, if you form this parallelogram, they are 180 degrees, right? So the angle theta will be equal to 180 minus 150.1, which is 29.9. Do you see that? So we can use this angle to find some magnitude. Perfect. So we can say magnitude of a plus b is equal to square root of, let me write down direct now, a square, which is 10, plus 14 square minus 2 times 10 times 14 times cos of 29.9 degrees, correct? So that gives you the magnitude. Perfect. So that is how you're going to find it. So let's calculate. So it is square root of 10 square plus 14 square minus 2 times 10 times 14 times cos of 29.9. 29.9. I should close the bracket actually. And then we'll say equal to. So we get 7.298. Or approximately, you can say that the magnitude is 7.3. Is it okay? So that becomes the answer for the given question. So I hope the solution is clear to you. That is how we could find the solution. You will note that the sum of the two vectors is much smaller than the difference. The angle in this particular case is an obtuse angle. So in such a case, that will be the case. Is it okay? So it makes sense. So let's move on and do question number 6. Question number 6. Given vector A as 4 minus 3, 12 in the component form and vector B as I minus j, find unit vector A minus B, right? So we need to find the vector A minus vector B. That means we can say, we can write them in component form I, j, k. So k is 0. So 1 minus 1, 0. Minus vector A, which is given to us as 4 minus 3, 12. That gives us 1 minus 4 is minus 3. Minus 1 plus 3 is 2. And that is minus 12. Correct? So that becomes the vector A minus B. So you could write this in either form. So if you are writing in ijk form, then in that case it is minus 3i plus 2j minus 12k. Correct? Where I, j, k are unit vectors along x, y, and z axis. So that is the vector. We need to find unit vector, right? So unit vector will be, so unit vector of A minus B. Unit means its magnitude should be 1, correct? So we have to divide this by the magnitude of the vector A minus B. Then we get unit vectors. This is what is required. So let's find the magnitude of this vector. So the vector is minus 3i plus 2j minus 12k. We have to divide this by square root of minus 3 square plus 2 square minus and plus 12 square, right? Or plus or minus doesn't matter, since when you square it, it becomes positive, correct? So we can now write down square root of 3 square plus 2 square plus 12 square is equal to square root of 157. So that becomes the the denominator, right? So I'm sorry, I should actually write like this. I should write this vector on the top divided by square root of 157. Let me write down here. So it is minus 3i plus 2j minus 12k divided by square root of 157. right? So this magnitude is square root of 157. So the vector could be written as minus 3 over square root of 157 I plus 2 over square root of 157 j minus 12 over square root of 157 k. Right? So these are unit vectors, and that is the nomenclature. Right? So that becomes unit vector A minus B. Correct? So that is our answer. Now let's see what is question number 7, 8 and 9. Question number 7. What is the product of vectors A and B? 4 choices: scalar, we are given a vector, a general vector, or it is not defined. We are not saying scalar product, dot product, or cross product. We're just saying product. That means what is A times kind of, right? I should write times B. Now in vectors, product is not defined, so the option is D, right? Either we have a scalar product, right? So what is defined is this scalar product, and you may learn dot product and cross product in coming chapters. But you have been told already that there is no term called product of vectors. Okay, so that is, be careful. Question 8. Provide examples of 3 linearly dependent vectors in a rectangular prism. So let's make a rectangular prism, let's say like this kind of thing. Okay. Now for simplicity, let me take this along, let's say XYZ plane, right? So let's say this is how it is. Is it okay? Now what we are looking forward to is provide example of 3 linearly dependent vectors. Now linearly dependent vectors, if we have 3 vectors, let's say x, y, z, so that means like ax plus ay plus by plus cz should be equal to 0, right? So the combination should be 0. So one of those combinations could be this, right? We could go like this. We could go something like this, correct? Into this and then come back. Do you see that? So it becomes 0. So if I have this point as OA, B, right? So the combination could be vector OA, vector AB, and BO. Now these are in the same plane, the plane of this paper, and their combination is indeed equal to 0 vector if I am going to add them up, right? So that is how we can show linearly dependent 3 vectors. Question number 9, right? So for some of you, let me draw it on the top. It will be better to be seen. It could be kind of like this also, like this side, one vector, the other vector, and third vector. Correct? So if I direct it like this, you see the combination is 0, right? So that is how you could do. Question number 9. The sum of 3 unit vectors is 0. Find the angle between them. Now 3 unit vectors can be 0 only under one condition. That is, there are 3 unit vectors. That means a triangle with equal sides. Is it okay? So that means we know equilateral triangle. Does it make sense? So we are looking for equilateral triangle. Now the trick part here is, what is the angle between these vectors which form equilateral triangle? So that is what we are looking for. Is it okay? So the sum is 0 in equilateral triangle. So what is the angle between these 2 vectors? Well, the angle is when you place them tail to tail. So this is the angle we are talking about. Similarly here, this is the angle we are talking about. And in this case, that is the angle. And now you know this angle is 120 degrees. Do you understand? So the vectors, you could say U, V, and W. There are three different vectors. Magnitude may be 1. So the unit vectors with angle of 120 degrees can result into a zero vector. Do you see that? Vector. So their sum could be 0 provided the angle is 120 degrees. So that is how you are going to solve this particular question. Now we are at the end, question number 10, which is the last question. So I'd like you to try this out and then look into my suggestions. Question number 10. Prove that the vectors -3, 4 and 2, 3, 2 can span any vector xy in R2, 2 dimensions. Use your method to span 8, 6. Right? Now, as we can see, these vectors given to us, let's call them vector u and v, right? So what we say is that vector u and vector v are not collinear, right? This implies that they can span. They can be basis vector, right? They can span R2. Is it okay? Now, when I say they can span R2, that it really means that I should be in a position to write any vector xy as a combination of these two, right? So as a combination really means A times the vector u, which is -3, 4, plus B times the vector v, which is 3, 2. That is what we mean. Where A and B are not both 0, correct? Of course, right? So that is what we mean. Now how do we solve it? From here, we can say x is equal to -3a plus 3b, correct? And y is equal to 4a plus 2b. So that becomes our equation. Now the idea is, for any value x and y, we should get a and b. So let us isolate a and b. That is the whole idea, correct? So let's call this as equation 1, this as equation 2. Now to eliminate one of these variables, what we can do is we can multiply equation 1 by, let's say 2, and equation 1 by 3. So if we do that, then what do we get? We get x is equals to, 2x. When I multiply by 2, it becomes 2x equals to -6a plus 6b. And this equation becomes 3y equals to 3 times 4 is 12a and 6b. Correct? So that is what it results into when you multiply first by 2 and the second equation by 3. Now what we can do is we can take away one from the other, right? So we can take away one from the other. So if I take away, let's call this as equation 3 and this is 4. So now what I will do here is that I will do equation 4 minus equation 3, right? So this minus that. That gives me 3y minus 2x equals to, b's cancel, but here we get 18a. 18a. So we get a in terms of x and y. Do you see that? So we could write this as 3y minus 2x over 18 equals to a. Do you see that? So we have found a in terms of x and y. So any x and y, we can find a value of a. That's what we're trying to say. Perfect. Now, we could actually substitute this value of a and find what b is in terms of x and y from this equation. Or what we will do here is we could multiply this equation now by 4, right? So we can redo this operation. This time we'll multiply equation 1 by 4 and equation 2 by -3. So if to this set I do the operation which is 4 times these two numbers we're looking at. Is that okay? To eliminate a's. So 4 times, if I write, I get 4x equals to minus 12a plus 12b. And here if I multiply by 3, I get 3y equals to 12a plus 3 times 2, 6b. And if I add these two, correct? So if I add these two, that is to say now, we are trying to add this, then these terms will cancel, correct? And what we get here is 4x plus 3y equals to 18b. So what is b equals to? So we can write b as equal to 4x plus 3y divided by 18. Does it make sense? Just divide it. So we get a formula of finding a and b if x and y are known. Perfect. Now using this formula, we can span the third vector 8, 6. So I hope these steps are clear. That is how we do part 1. Perfect. Now let's do the other part, which is we have to now write 8 and 6 in terms of combination of these two vectors. So 8 is the x value and y value is 6. So what is a equals to? So a equals to, we'll replace y with 6. 3 times 6 minus 2 times 8 divided by 18, which is 3 times 6 is 18 minus 2 times 8 is 16 over 18. So we get 2 over 18 or 1 over 9. That's the a value. B value will be 4 times x is 8 plus 3 times y value is 6. We are using this formula, right? Over 18, 4, 8, 32 plus 6, 3, 18 divided by 18. 8 plus 2, 10. 2 plus 3, 5. 50 over 18, correct? So dividing by 2, we can get 25 over 9. So we can write now the vector 8, 6 as equal to 1 over 9 of the vector minus 3, 4 plus 25 over 9 for the vector 3, 2. So we could write this as a linear combination. So that means we could actually span any vector, right? So that's kind of proof for our formula. So I'd like you to go through this and understand what we have done in Unit 1 of Introduction to Vectors. So I hope that makes sense. Feel free to write your comments and share your views. If you like and subscribe my videos, that'd be great. Thanks for watching and all the best for your exam.